How do we find domain and range of functions? Interesting. In this video, we have 6 graphs for you to explore, and in the playlist, many more examples. Master the strategies and enjoy the journey of learning. Thank you. How do we write domain and range of function when the graph is given to us? We'll look into this particular topic with the help of 6 examples. We'll also understand different ways of writing domain and range. In the following videos, you will see how do we write domain when the equations are given to us, or when piecewise functions are given to us, or when composite functions are given to us in this particular playlist. Feel free to explore, and wherever you have any difficulty, you may ask questions and send an email on globalmathinstitute at gmail.com. You can also write comments which we regularly respond to. So, here are 6 questions for you. You can always pause the video, answer the questions, and then check with my solutions. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Our channel is absolutely free for last 15 years with 17,000 videos. Now let's check how do we find domain range for the given function when we are looking at their graph. We'll begin with question number 1, where we have a parabola. As you can see, domain is the x values. What x values can it take? And range is the set of y values we get. So let's write down the domain of this function. So domain, as you can see here, the function starts at this particular point, and this is at 4, right? So the domain is x belongs to the set of real numbers where x is less than equal to 4. We'll assume that the starting point is included until and unless a hole is given to us. And the end point showing out of the graph, we'll assume there's kind of an arrow right there and it extends forever up to infinity. So that becomes the domain for the given function. And now let's write down the range. Range is all the y values. So y values belonging to the set of real numbers. And as you can see, we have a minimum point here, right? It opens upwards. The minimum point is at -3. And therefore, range is for y greater than equal to -3. So that I hope is absolutely clear. Now let's continue and answer question number 2. In question number 2, you see the orange vertical line is actually a vertical asymptote. This is a graph of a reciprocal function translated 1 unit to the right. So can you write down the domain of this particular function? Let's write down the domain first. So domain, as I said, x belongs to real numbers. And what is not included? Well, this point, which is x equals to 1, the vertical line along this x value is not included. So x is not equal to 1, right? We have a vertical asymptote at this particular point. Now, can you write down the range for the function? Range is all the y values which belong to set of real numbers. And as you can see, y values which are not included is 0. Do you see? It approaches 0 as x approaches infinitely large value. So we see that y is not equal to 0. So that becomes the range of this reciprocal function. Is that clear to you? Perfect. Well, if you really want to learn from me directly, feel free to send an email on globalmathinstitute at gmail.com. Our students are right there on the top. They get scholarships and admission to the best universities at times. Right, so now let's take up question number three. Question number three, a very interesting function. Can you write down the domain here? Well, the domain, as you can see, is all real numbers, right? There are no restrictions, right? So x belongs to real numbers, and as far as the range is concerned, we see that y also belongs to real numbers since it's a line, a curve, right? Solid line is being shown to you, but there is one thing, it has an absolute maximum value of 4, right? So we say that y, and it is not touching the horizontal axis, so y is greater than 0, however, less than equal to 4. Do you see that inequality? So y is less than equal to 4, but is greater than 0. It is non negative, less than equal to 4. So that is how you are going to write the domain and range of this function. So first three were kind of straightforward, and now we get into a tricky part. Question number four, we're just given some coordinate points, and we need to now write the domain and range. So in such cases, I will first write down the function itself, and these coordinate points can be placed in curly brackets. A set of these points define the function. So let's start reading the function. So leftmost point is at minus 2, right? So we'll write minus 2, minus 2. Then minus 1, 3. So carefully read these points 0, 2. And then we have 2, 3, right? Let me write here 2, 3. And then we have 3, 4. And then we have 4, 1. So that becomes the function for us. You'll see that for each x value in the domain, we have exactly one y value. Now the domain in this case is all the x coordinates, right? So I'm writing d of x is equal to, so this is called rooster form, okay? So the domain is all the x values minus 2, minus 1, 0, 2, 3, and 4. How about the range? Range, the y values, we can write down as minus 2, 3, 2. Now 3 is again there, but you don't have to write it twice. It has already come 4 and 1, right? 4 and 1. It is better to write them in increasing order, right? So we may rewrite this as minus 2, right? 1, 2, 3, 4. It looks better, but both are correct answers. Is that clear to you? So when you're given set of points, as in this particular case, you need to write down the function, which is set of coordinate points. All the x values are part of domain and y values are range. Correct. Feel free to contact me on the given address. We can help you achieve your goals and do much better. Thank you. Let's move on to question number 5 now. So what we have done is we have a piecewise function. You can see that we have something from minus infinity to 0 and then from 1 to infinity. So what is going to be the domain of this function? So domain of this function is x belongs to set of real numbers, and it is from minus infinity to 0 where 0 is included, right? So we could write like this, minus infinity to 0, right? 0 is included, so close bracket. You see that? Comma, and then from 1 to infinity, 1 is not included, and infinity cannot be included. So do you see how we have specified the interval in this particular case? Infinity can never be included, so the parenthesis shown is open and 0 is closed, right? Now write down the range for this function. So we say y belongs to real numbers. Now, as you can see from here, y is greater than 2 and y is also equal to minus 2, right? So we say y equals to minus 2, comma, or you can write union or you can write or. So there are three alternatives to this. You can write union, this means union, or you can write just the word or, okay? And then we have greater than 2, right? Not equal to, right? So that is how you have to write range of this function. You see how we are looking into different nomenclatures, right? Different ways of writing. So it's kind of tricky. Now we have the last question here. You can pause the video, answer it, and then look into my suggestions. So here we see there are two vertical asymptotes. So in the domain, we have a restriction. We say x belongs to real numbers. However, x is not equal to. So this is minus 2 and also x is not equal to 1. Is that clear to you? So look at the vertical asymptote for restrictions in domain. As far as the range is concerned, so the range y values, you can see all y values are there, right? So there is no restriction on y values. This is going through the origin also, right? So there is no restriction on the y values. So that is how you have to write domain and range of this particular function. So with that, we have learned different types of graphs which you could get in your test, right? And you can now write easily domain range for such functions from the graph. I hope that helps. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thank you and all the best.